Welcome to Ask and Learn.
Hello everyone. In this problem, the node equation for a parallel RLC circuit is given by dV by dt plus 50V plus 100 integration V dot dt equals to 110 cos factor of 377 t minus 10. Now we have to find out the value of V of t in this equation, in this problem, by using the phasor method. By using the phasor method, right? So now, for calculating the value of V of t, first we have to convert this equation. This is the time domain equation, right? This is the time domain equation. Why? Because of all of these quantity are given in the form of time domain. So first we have to convert this time domain equation into the frequency domain. Okay. So what happened for converting the value of dV by dt? This is the time domain approach. This is the time domain approach. And when we convert this time domain approach into frequency then it is simply written iota omega, and this is the function of voltage V, so we can write V. And for converting the integral value V dot dt, it should be V iota and omega. Okay. So now convert this equation. Okay, one more thing. Here we need a value of omega. Okay, so now in this problem, the omega value is 377. How? Simply the equation of voltage and current is written by V equals to Vm sine of omega t plus minus angle theta. Okay, sometimes this angle will be 0. Okay, so when compare this equation, this is the magnitude Vm and cos factor by converting sine factor, cos factor or sine factor, and this is the value omega t. So omega is 377. Here omega is 377. Okay, so now convert this frequency domain, this time domain equation into frequency domain. Then dV by dt equals to j omega of V, j omega V plus 50V, no changes, plus 100 V upon j omega equals to 110 and angle of minus 10 degree. Angle of minus 10 degree. This is in time domain and this is in frequency domain, or we can say that phasor form, right? Now simply by solving this equation, simply we take V as a common. So V j by putting the value of omega 377 plus 50 plus 100 upon 377 iota equals to 110 angle of minus 10 degree, right? Now by solving this equation, iota 377 plus 50, we can transfer this iota into numerator form, right? So it is simply minus iota 100 upon 377 equals to angle of minus 10 degree. It is clear? So again, if we solve this equation, the result will be 50. This is the real part 50. By subtract these two values, it give plus iota 376.73 equals to 110 angle of minus 10 degree, right? Now this is the complex quantity and this is the phasor form, right? This is the complex quantity, this is the rectangular form, or we can say rectangular form, right? So first we convert this phasor form into this form. Now by using this formula, the magnitude m equals to square root of a square plus b square, and phi angle will be tan inverse imaginary quantity upon real quantity, right? So by applying this formula, the magnitude will be 380.6 and angle will be 82.45 degree equals to 110 angle of minus 10 degree. Now calculate V equals to upon 0.6 angle of 82.45. It's clear? Now simply by divide V equals to 0.289, we simply divide this magnitude 110 divided by 380.6, and by solving this angle minus 10, and we shift this 82.45 into numerator form minus 82.45, then the answer will be 0.289 angle of minus 92.45. So this is the value of voltage. When we convert in the cosine form, then V equals to 0.289 cos of 377t minus 92.45 degree. This is the answer. It is clear? This is the answer. So what we have to do in this problem? In this problem, simply a equation is given which is in time domain. So first we convert this time domain approach into frequency domain, which is by using this function. Okay, then we have take simply V as a common, and simply we apply the mathematics rule and find the value of the voltage in the phasor form. Thank you.